Welcome to our 11th webinar, and this is where we're going to take a deeper look into our diesel locomotives and some of the lesser known features that are built into our Tsunami2 decoders so that you can really enjoy your operations. So really quickly, just want to introduce myself if you guys are not aware. My name is George Bogatuk. My primary function here is a product specialist. So I've been around all of this, and one of the things I want to point out is at some point I was a beginner at everything, and everybody at some point had to learn about model railroading. And so whether it be building bench work, laying track, wiring the track, building locomotives, detailing locomotives, building scenery, making mountains, making trees, all of that. Somebody had to learn all of this at some point. So one of our goals in all of this is to help educate you guys, give you the tools you need to get the most out of your hobbies. With that, let's get into the webinar. So first off, what we're going to do is we're just going to review some of the Tsunami2 Diesel sound sets. We're just going to kind of show you where all the sound files live and how to find it. We're going to talk about setting up sound roster and dynamic digital exhaust and what that means and how it can be beneficial for you. We're going to highlight some of the lesser known functions in the decoder, some things that will really help give you a better feel for what's actually happening so you can more realistically recreate this on your layout. And then last thing, we're going to show how a lot of these functions go to the prototypes. So let's go ahead and get into the clinic here. So first of all, we're going to talk a little bit about the diesel sound sets. The Tsunami2 Diesel sound decoders are each pre-programmed with up to 9 different diesel prime movers in each decoder. And there are 4 major manufacturers, and so if you look at the list, yes, you're going to see 5 options. There's EMD and EMD-2, and we'll get into the difference here in just a minute, GE, Alco, and then what I lovingly refer to as the land of misfit toys, known as the Baldwin and others. Now with that, every single decoder in the diesel side of it share a common set of 44 different air horns, 14 bells with different ring rates, giving us a total of 50 different bell choices, dynamic brakes, independent train brake sounds, fuel loading, cab chatter, fireman ed, and all these other sounds. And so really the only major difference, that you're going to hear is the differences in the prime mover. So let's talk a little bit about the differences and what you're going to see in each of these decoders. So first off is our EMD. This is the one we've announced and been building since the very initial release of the Tsunami2. And you'll see a lot of the most common diesel engines that you're going to find on most EMDs, including the 16-cylinder 567 non-turbo. With the transition, you're going to see 567 turbos and so forth. And if you look at the list, you're actually going to see prime movers that are all the way from the beginning of the diesel era all the way up to modern day, including the 710 G3T2 up to the SD70 Aces. The difference is between the EMD2 or the EMD-2 is you're going to see a same type of set where you've got 567s all the way up to 710s, but these are some of the more specific, maybe some unique sounds to them. For example, the 12-cylinder non-turbo, non-transition doesn't really sound much like a 567. It's really unique sound. And including the 20-cylinder there for the SD45 series. So take a look at this, spend a few minutes, look at your prototype, what you're going to install the decoder into, and you can match the prime mover to whatever it is that you're putting it into, and then you can pick the EMD or the EMD2. The reason there's 2 of them is because the memory chip doesn't hold enough memory to be able to put all this on one decoder as much as we would like without redesigning the decoder. So at this moment, it lives on 2 decoders. So next up, we have GE. You're going to see a whole range, again, from early GE models going down to industrial switchers and the early FDL12s up to the FDL16s, modern GEVOs, including the Evolution Series Tier 4s. All of this lives on the GE decoder. Next up, we have Alco, and you're going to see a wide range of different Alco prime movers and variants thereof, including, for example, the inline 251. Now, a little fun fact for you, the Alco diesel engines were labeled based on the date that the project was done, and so you're going to see they've been really busy in the early part of the year because 539 actually stands for May of 39. 244 is February of 1944, and so on. So you can kind of see that it doesn't really relate to a size or anything like that. It just has more to do with the dates that they were doing it. Again, be sure to research your prototype. Next up, we have our Land of Misfit Toys, the Baldwin and others. Part of the reason we call it the others is you're going to see a lot of different models that didn't justify a separate part number or its own dedicated item. We've got 4 Baldwins, including the VO and some turbo and non-turbo versions of the 606 and the 608. But you have noticed here the Galloping Goose, and this is the small little rail car, Pace Aero, that is going to be a gas type engine, so you do have an option for there. There's the dual Whitcomb. We do understand the UP gas turbines were General Electric, but again, it came down to space, and we had space here, so we've put it in here as a other. And then you're going to find the NRE genset. And this is a really cool one because we're going to talk about a lot of features here today, but the coolest feature about the genset is the dynamic digital exhaust actually applies great because the gensets, the second and third genset engines will kick on as needed. And so our dynamic exhaust will notch up as needed based on the load on the motor, and so it's a really cool effect. We're going to talk about some of the sound selections here, and we're going to set up some of the sound. We're going to set up our CVs for some of the just basic configurations, and then we're going to use the decoder. So first off, I know we've talked about this quite a bit in past, but the Tsunami2 sound selection allows you to select the sound. So kind of going back to that prime mover list, I'm going to jump around here a little bit. In the middle there, you're going to see select prime mover. Well, that list is going to be found on the sound selection reference for the respective decoder. And then you can go through and find the CV value that corresponds with the prime mover that you want. So say, for example, if you're doing an original EMD and you want the 645 non-turbo, then you're going to set CV 123 to a value of 4. Now, the other thing I want to point out here is what's called pitch shift. And a lot of people have asked, what is this for? And what this is designed to do is to give you a unique sound for all of your prime movers without forcing you to have to then either purchase a different decoder or spend an hour or more in front of a computer downloading and so forth. Now, part of the reason we decided to go with the pitch shift is because I could take the same locomotive and record it from 4 different angles and get 4 different recordings. Come back into the studio lab and mix it up and then tell you it's 4 different locomotives. Now, because of that, there are some audio tricks that you can do to help, give you that feeling that they're all different. So with this guy here, I'm going to start him up. We'll get that locomotive diesel engine fired up, and I want to kind of show you what the pitch shift does. So now once that, you can hear that prime mover whine. But what I'm going to do is I'm going to take the pitch shift and I'm going to drop it down all the way to the lowest setting. So when I hit enter here, you're going to hear that change. You still get that same characteristic of that prime mover, but now it sounds a little bit different. Now I'm going to take that same prime mover here and I'm going to move it all the way up so you can hear a more drastic change. And that's kind of what we're doing here. You still get the same overall flavor of that prime mover, but it does give you some variance so that way you can adjust it for your own tastes. So we'll move it back here to the middle. Now, a couple of other things you can do is you can select the air horn in CV120. As we mentioned, there's 44 different air horns to choose from. So again, looking at my locomotive here, I can blow the air horn. And I'm going to go through here and I'm going to change CV120. And just make the change. So again, I don't have to spend time in front of a computer downloading to make the specific file. I can make a CV adjustment and you're going to get that change. Now when we talk about the bell, again, you have 0 to 49, which is 50 bell choices, and these have to do with the different ring rates. But one of the things to note is if you want to have the bell triggered automatically when you blow the horn, like this, you would find that bell choice that you want and then add a 128 to the value. And what that does is it tells the decoder to trigger that bell every time you blow the horn. Now, as a throw out to real engineers, one of the most annoying sounds is the bell, especially when you're sitting in the cab. Because for you and I, when we're standing next to the train passes, the bell goes away. But for them, they're sitting in the cab. So when we blow the long horn, which is function 2, it will trigger the bell. But if we're trying to do whistle signals, such as 2 short blasts of the whistle,
or the air horn in this case, then the bell, the engineers are trying to hit that button so quick that it doesn't trigger the bell, and so we threw them a bone. So the F3 button for the short horn doesn't trigger the bell, but then when I blow the long, you hear it trigger the bell. Now we also do have a long and short because again we're wanting to reproduce the whistle signals that engineers use. Now a couple of other things here, you can select the type of air compressor in CV124, you can select an air dryer or a poppet valve in CV125, and this is a type of way that when the air is compressed, moisture condenses and it has to be expelled. And so what you're hearing on this locomotive is actually a air dryer sound, but we can change that to a poppet with CV125. So now you're hearing that sound. And this is one of the extra steps that we've gone to give you the ability to match your locomotive with the decoder so that you get a more realistic sound. The air dryers really didn't come into practice until about the early to mid 90s, and so if you're modeling 1978 or especially 1950, you'll want to set that to a poppet valve. Now by default it comes triggered to a air dryer, so you'll want to go through and change that. Now other things you can do is change the coupler, and there's a couple of different choices there.
Now when we get into some of the sound setup, there's two CVs really that'll help adjust the overall performance of the locomotive. One of them is CV112. Now there's a few things that it does. One of them is that when the emergency stop sound is played, the prime mover can actually either drop to idle or go into full shutdown. We've seen documentation for both. So in order to allow you to select and match your prototype, we put this in here as a selection. So when you throw the e-stop, it'll either force the prime mover to idle or shut it down. The next one is a low pressure alarm bell. So when we started up the locomotive, you heard that low pressure alarm bell. This is a selectable sound. So if you want to hear the alarm bell, you can turn it on. If you decide you don't want it, turn it off. It's set in CV112. Now, another one you can do is what's called a generator select. Function 20 enables a steam generator by default. But if you're modeling one of the more modern diesel locomotives that have an auxiliary diesel head-end power, and we'll talk about head-end power a little bit further on, but if you have one of these like the F59 PHIs or MP36 or something, you'll want to trigger that secondary diesel HEP. And so in CV112, we've given you the ability to select which one so that way you can customize your model. Now, for most of you guys in the 50s and 60s, a steam generator is going to be exactly what you're going to want. So early in the steam era, steam heat was used for the passenger cars. And so when you had heat going to the passenger cars, it was in the form of steam. So if you were in the last cars, it tended to be colder than it was in some of the first cars. And so when diesel started taking over, they obviously didn't operate on steam, so they had to generate the steam. And so you have a steam generator sound. And for those of you guys who don't know what this is, we're going to go ahead and
kind of show you here on the camera. This setup right here towards the back, let's see how, there we go. There's a better setup. On this, the F45PH, you're going to see this, these steam generator appliances there at the back. And basically, it's an onboard boiler that creates steam so that way they can use the steam heat in the passenger train. So when you're running your passenger trains, you can use the F20 to turn it on.
And then the last thing we'll talk about is what's called true idle. And true idle basically allows you to have to notch the prime mover up higher when you go to notch 1. Most of the time when you go to speed step 1, you hear the prime mover notch up. Well, this is something that was basically a feedback thing we got from the original Tsunami, where we actually did not notch up the prime mover when you went to speed step 1, because in the real world, when you actually go to notch 1, it does nothing more than activate the traction motors, and it doesn't really change the prime mover sound. Well, now with things like the proto throttle, people are becoming a little bit more aware and educating themselves on how a locomotive operates. So in this case, we decided to give you the option to enable true idle, where you go to speed step 1 and the prime mover stays the same, or you can go to speed step 1, you can hear it notch up, it's up to you. Now in CV114, we actually have a handful of different things here that we can do. One of the things is we can adjust the prime mover auto notching. By default, it's set to about 7, so every 7 speed steps you move the throttle, it's going to increase the diesel engine RPM. Now, when we talk about our dynamic digital exhaust here up next, we actually encourage you to set that to a value of 15, and what it does is it gives a smoother response between the notches, so that way when you're running either over the grade, or if you have multiple locomotives together, you're going to get a more evenly distributed sound, and they're going to notch more closely together. You can also disable auto notching here, and by setting the auto notching rate to 0, now you have to use by default the function 5 and the F6 as RPM plus and minus to increase and decrease the diesel engine RPM. So again, it's up to you how you want to do it. A couple of other things here is the prime mover interlock, and what that does is that prevents us from moving the locomotive if the prime mover is not running, but it also prevents our locomotive from shutting down the prime mover if we're still moving. So that way you can't accidentally push the F6 button too many times to shut off your prime mover if you're still moving. This is also where the auto start bit lies. An auto start bit is worth a value of 32, so the default value for CV114 is 39, which is 7 for every 7 speed steps, plus 32 for the auto start. And what that says is every time track power is applied, it automatically starts up the prime mover. Now on my layouts, I disable this, and my engineers have to actually start up their diesel engines, and that's where F5 comes into play. So they can start up the prime mover before they get going, and that's how we started this guy up here just a minute ago. And then the last thing is dynamic brake. Now we'll talk a little bit more in depth about dynamic brake here in a little bit, but there's 4 basic modes of dynamic brake override. One of them is it doesn't affect the prime mover at all. The other 3, typically EMD will force the prime mover to idle. Alco and GE will force, and especially the GE early versions, would force the notch 8. And then Southern Pacific by railroad would go to notch 4. And the idea behind that was to make sure the main generator was creating enough electrical energy so that the traction motors would keep the blowers going and keep them cool and keep them from overheating. So here's where you can take a little bit of time to do some research and find out which way you're going to do. Now, dynamic exhaust, first of all, this is a way that we allow the prime mover to change based on the load. It's going to affect the intensity and the throttle notching based on what the locomotive is doing. So instead of just running at the same notch up, down, around corners with, pick up 30 cars and it's still the same notching, this allows the decoder to automatically calibrate and adjust the prime mover sound. So you don't have to be pushing buttons on your throttle or locking your speed in order to adjust the prime mover sound, things like that. This allows the decoder to do it. Now we're going to go ahead and calibrate this really quickly, and we're going to show you how to do that. To do this, we're going to take CV32 and set it to 2, and that is the 2-dot part of our CVs. And what we're going to do is we're going to take CV503 and we're going to set it to 255 while the model is moving at speed step 1. And what this is going to tell the decoder to do is it's going to interrogate the power consumption of that motor, and it's going to create a point on a chart. It's going to say, okay, here's how much power the motor needs at the bare minimum to get started. Then we're going to basically do the same thing, but we're going to get it moving at about speed step 25 or 30 or something like that when the locomotive is moving. And then we're going to set CV504 to a value of 255. And that will interrogate the decoder, again, how much power is being used. And I recommend this actual speed step doesn't matter, but if you have a speed that you typically run, this is what I encourage you to do this at. And then the decoder will calibrate and say, okay, the motor needs this much power at speed step 25. Then it basically creates a power consumption chart and uses that as a reference. And then the last one is CV2.512. It will determine how sensitive the decoder is to changes in the load. And on a diesel engine, especially since we typically run multiple units, I tend to use this at a fairly low sensitivity, somewhere around 25 or 30, so that way you get a nice even temper between. So let's go ahead and do this really quickly.
So we're going to unmute. We're going to start moving our locomotive forward at speed step 1. Now I'm going to program CV32 to 2. Again, the 2-dot part of the CV. Now I'm going to set 503 to a value of 255. Now the decoder has calibrated its motion and its power consumption. Now, normally I would recommend doing this at the same direction, but for the demonstration purposes here, we're going to do this in reverse. I'm going to get this locomotive moving at speed step 20 in reverse. Now, on my throttle, I'm going to go ahead and set 504 to a value of 255. But before I hit program, I'm going to release, let the locomotive settle its speed. I'm going to hit the enter button to set it. I'm going to grab my locomotive and I'm going to bring it to a stop. So you can do this in a relatively short space. So now what we're going to do is we're going to take 2.512 and we're going to set it to a value of 30. Just to give it some nominal, and you can play with this. You can always adjust it accordingly. So now we're going to move forward at speed step 1. You're going to hear that prime mover notching up, but then when I put a little bit of pressure on the locomotive to stop it, now you're going to hear that locomotive notching up. And then when I release, you're going to hear that prime mover dropping back down. And this is all based on load. Remember, I haven't changed the speed at that. It was at speed step 1.
So this is one of the reasons why you want to spend a moment and calibrate the dynamic exhaust, because there's a lot of layouts out there that don't have a whole lot of functions enabled, especially in operating sessions. And what better way to get that interaction and that feel of that locomotive pulling that heavy train up the grade or down the grade, or coasting down grade, or whatever the case is, than by allowing the decoder to automatically do it. And so therefore you're not wasting a function button to lock your speed, because most people aren't doing things like that anyway. So with this, we've got this auto calibrated so that now when your locomotive is moving, you'll actually hear the change. Let's take this one step farther. When we're using our auto notching, we do still have the manual override. So F5 and F6 still allow us to manually override our dynamic exhaust. So if we're going upgrade, say with 30 cars, and our dynamic exhaust only takes us to notch 6, but we want to be in 8. Well, we can press that F5 on twice to enable that prime mover to notch all the way up to 8. Now, once you're doing that, your decoder will actually override your override with the dynamic exhaust when you come to a stop. So the decoder is intelligently monitoring how you're using the decoder and will help keep you where your operating is. So when you come to a stop, your dynamic exhaust will override. So this gives you the ability to do that. Plus we also have F10, which is a straight to notch 8. So if you're going upgrade and you just want to hit the F10 and not worry about it, you can do that. If you're coasting and going downgrade and you want to go straight to idle and force it, or say you're coming into a station stop, you can hit the F19 straight to idle. The best part about all of this is, again, our throttle knob is designed to control the speed. You never lose control of your locomotive. You never lock the speed or anything like that. This is all done automatically, but you can manually override it if you so choose. So this is where it gets to be a little bit more fun and a little bit more enjoyable, even if you have limited functions on your throttle. So next up, we're going to take a look at the overall function mapping here, and you're going to kind of see a lot of function mapped things here that are pretty standard: headlight, backup light, bell, air horn, the short horn like we talked about. F4 is our dynamic brakes. We're going to talk about that a little bit more. F11 and F12 is our independent and train brake application, as well as our brake type select. So we're going to talk about how that works here in just a moment. But you're going to see some other things like handbrake, HEP mode, fuel loading, general service, and things like that. We talked about the steam generator. We're going to talk about a little bit more of these and what they are. Now, the beauty of this is what's called FlexMap. And our FlexMap function mapping allows you to make this chart for your locomotive no matter how you want it to be. Any reason you want the headlight to be controlled by function 22, you can do it. So you can make this mapping chart completely for your own customized. The other thing I wanted to point out is when you purchase an Athearn model or somebody else that has a Tsunami2 in it, a lot of times some of these buttons have changed. So the beauty is that you can go back into the flex mapping and you can either match your aftermarket decoders to the Athearn factory defaults, or you can go the other way around and match the Athearn models or whoever to the aftermarket function maps, or you can match them to your own. It's completely up to you. F0 turns on our headlight and backup light, as we know. And then function 24 through 27 uses and turns on our FX 3, 4, 5, and 6 lights. Now, one of the things I just wanted to point out really quickly here is what's called our diesel light.
Now, a diesel light is a little bit different effect than just a simple on and off. And so when we turn the light on and off, you'll actually see a quick fade of that light instead of an instant on and off. So if I change this headlight to an instant on and off, now you can see the difference. Now you're getting that instant change instead of that fade. And the fade is designed to help replicate the element getting warm and that light getting a little brighter. So I encourage you guys to play with that a little bit. But there's also a whole lot of other different hyperlight effects, including things like ditch lights.
Alternating flashing, ditch lights, strobe lights, rotary beacons, things like that. I know we've talked about this in the past, so I'm not going to spend a whole lot of time on it, but this is where it allows you to do that. F11 is when you turn on F11, it's basically activating the brake. F11 on, the brakes are on. F11 off, the brakes are off. Now, F12 will actually toggle between the two different braking systems. And so when you have F12 off, the decoder defaults to the independent, or as its name implies, when the locomotive is light or doing some switching. When F12 is turned on, it will actually change over and do the automatic brake sounds. Part of the reason we did this was because of ease. It's quick and easy to do. And the other side of it is, yes, we understand there's progressive braking and so forth in there, but how many times do you remember how many times you've pushed a button? Did I push that 3 or 4 times? Because you're focusing on running your train. So we wanted to make things easy but realistic. And so F11 basically just activates the brakes on. F12 determines which braking system you're going to use. The independent, it's the locomotive brakes, the brakes you see on the trucks of the locomotive. And then the train brake, or the automatic brake, distributes the braking effect throughout the entire train. Basically, when we bring the locomotive to a stop, and we're going to go ahead and run this guy here a little bit, just to show
you over real quick. We're going to go at speed step 10. Actually, I want to add a little bit of momentum. I forgot to do that earlier. You really want to add a little bit of momentum into your locomotives, because then you'll get a little bit more realistic spool up of the prime mover. So we're going to go at speed step 10. Start to move the locomotive. You can hear that prime mover spool up in a more realistic comparison. And then we're going to press the brakes. And you're going to hear the independent brake squeal, and you're going to see that locomotive come to a stop. Now when I press the F12, you're actually going to hear the train brakes switch over, but you're actually going to hear the compressor cycle as it works to charge the train line. And you're going to hear the prime mover notch up as it works to turn that compressor faster to charge the train line. Now in the real world, the train line takes about 10 to 15 minutes to charge, depending on how long how long the train is. In model train time, it takes 30 seconds. So once this drops back down to idle, the compressor just kicked off. So now we're going to go ahead and move in reverse, but remember our brakes are set. So it's not going to move yet. Now we release the automatics. You hear that brakes release. And now when I set the brakes, you're actually going to hear a different sound. And notice the brakes are not squealing, because the locomotive brakes are not actually being used. You're actually using the brakes on the rolling stock in the freight cars.
So when the independent brake is playing, you're going to hear the squeal of the independents. But when you turn on F12, it'll toggle to the train line, or the train brakes, and that's going to charge the train line. It's going to run the compressor, and all of this works together. Let's go in a little bit further depth with the independent brakes. So on the prototype, the brakes are what's called straight air, and basically when you open the brake valve, it applies air pressure into the cylinder. The cylinder then moves the lever applies the brakes to the shoes or the wheels of the locomotive and applies the braking pressure. Now when you have multiple locomotives, you can still have the independent brakes running back and forth, so you would still do that. Now when you're running this with F11 on and off, the F12 in the off condition, this is typically used for hustling around a yard, switching on a industry or a yard track and things like that. So it's a lot more realistic to do that. Now once you tie into the train, now you use the automatic brake. Now the automatic brake is then when you would turn on the F12, then you charge the train line, and then now your locomotive will work in conjunction with the sounds of the rolling stock, which is a feature we have in the sound card decoder, which makes a really cool sound effect. But basically, the air pressure in this case works off negative air pressure. So the pressurized system positive air pressure will basically release the brakes or pull the brakes off the shoes. When the engineer wants to do a brake set, he'll actually reduce the air pressure in the train line, and that reduction in air pressure then allows the brake shoes to be applied to the wheels and help distribute that braking. And this is where the progressive braking really takes effect, because they usually do a 5-pound set or a 10-pound set. But given the fact that we're working with this, again, you don't know how many times you push the button or so forth, you can just set it in your model, turn it on and off. You can always feather the brakes, turn it F11 on, turn F11 off, turn F11 on, turn F11 off, and with a little bit of practice with your momentum settings and your braking rates, you can stop your train on the tie that you're looking at. With this, again, with the sound car, it distributes out the sound, so when you hear the air pressure reduction on the locomotive, you'll actually hear the squealing coming from the cars, which again is the more realistic scenario. Now, dynamic braking, what it does is it takes the electric motors on the axles and turns them into electrical generators. It's that electromechanical resistance of generating that electricity that slows the rotations of the wheel to help keep the train, in this case the locomotive, under control so that you're not running away. If they were relying straight on the independent and the automatic brakes, they would wear out brake shoes by the time everything was done. That electrical energy then has to be dissipated somewhere. So you usually see that dynamic brake blister there on the top. That's a grid of resistors, and that's where the electrical energy is sent to help slow the electrical energy down and get it where it blows the wheels down. The sound you're actually hearing is the fan that blows air across that resistor grid to help keep those resistors from overheating, because of course electrical energy running through a resistor creates heat. When we're doing this with the Tsunami2, we talked about briefly about adjusting the prime mover sound, but now you can actually change the speed and we'll actually keep the train under control. Once you crest the grade on your layout, you're going to press the F4 one time, and you're going to hear that dynamic brake fan kick on. You're going to hear the prime mover be affected how you set it up, and that goes into dynamic braking low. Once your train is fully crested and you're on the downgrade, your locomotive or your train in the real world will then be pushing all of that gravity, would be pushing that train down the tracks faster. So that's where we can then implement a dynamic brake high. So we're going to press the F4 a second time, and that's going to go into dynamic brake high. That will then enable a second braking rate in CB116 that will actually slow the train down to about speed step 8, 7 to 10 miles an hour, something like that, to help keep the train under control. Now, as a way to let you know, you're going to hear the fans kick up in intensity. And it will keep that train at that speed regardless of throttle setting unless you bring it to a stop. Now, dynamic brakes will never actually stop the train. They'll bring it to a controlled speed, but they won't stop it. So if you stop it, then of course there's no longer any braking effort on it, so the fans will kick off and the dynamic brakes will shut off. But if you have not exited, then as soon as you start moving again, you'll hear those dynamic brake fans kick up. Now on this, we've actually got a long video that's on our YouTube channel that you guys can check out. I'm running a little long, so I'm going to refer you to the video that's on our YouTube channel for a demonstration of this feature. Next up, passenger guys. The head-end power for some of the 70s, 80s guys with the F40 PHs when they came in about. By that time, passenger trains started switching over to electric power. So that's where head-end power, HEP, came in. What it typically does is it uses the prime mover to generate electrical energy to keep the lights on and any other electrical appliances in the passenger trains. As we talked about, early 50s and 60s guys, this is a steam generator, and there is no HEP power. So when we're doing this, function 16 will actually turn on the warning bell, and then it will notch up the prime mover. Now on EMD and Alco and some of the Baldwin and others that I realize weren't really equipped with it, but it's part of the software, that would run up to notch 8. But on GE, in the P42s that you see there in the picture, and I have one over here and we'll show you here in just a second, it'll actually run you up to notch 6. So this is what's really fun, is when you have this and you enable the function 16, your prime mover will stay in notch 6 to keep the passenger train powered, But if your dynamic exhaust determines you need more than notch 6, it will increase the diesel engine RPM, and then if you don't need it, it will drop back to 6, but it will never drop below 6 as long as function 16 is there. Now, function 20, as we talked about, enables the steam generator, or if you've selected the HEP diesel pup motor, it will enable that as well.
Now I'm going to turn on function 16 so that you can actually hear the HEP start up. So now the locomotive is at notch 6. I'm going to put my microphone a little closer to it here. So now it's at notch 6. So let's say we start to move a little bit here. And we need more. You're going to hear that diesel engine increase. And it'll drop back down if we don't need it. And then we bring it to a stop. And you're going to hear that that prime mover is always at notch 6. Now another little fun thing about this, and I'm going to go ahead and mute this guy back up, and we're going to put him back away.
But the other fun thing about a head-end power, and this is something that's good to know, is that typically the engineers would not put it, if they had multiple units, they wouldn't put it on in the locomotive they're in, because as you could imagine, that would be loud, the locomotive would be shaking all over the place, it would make it a more uncomfortable ride. So if they had a second unit, they would actually put it in the second unit and turn it on. If they had 3 units, it would still be in the second unit. And the reason for that is because the engineers would not walk all the way to the 3rd unit if they had to address the issue. So that way, it wasn't in their unit, but it was in the second unit, so they didn't have to walk as far to fix it or adjust it or play with it. So when you build your consist, you can take function 16 and enable it only in your second unit, so that way when you send your command, it will turn on the HEP in the second unit, not the first, and then you can run your train. It'll be a more realistic scenario. So some of the other sounds that we've got in here, Fireman Ed. And Fireman Ed performs many tasks, including fueling the loco. When you're doing a fuel loading pad like that, you can stop your locomotive, hit the F17, and your locomotive is going to take on fuel. F18 also triggers Fireman Ed to do some general service, such as cab door, wrenches, pneumatic lubricators, other things like that. And then there's some other automatic sounds that you're going to hear playing in the background, such as the AC unit, cab chatter, yes, the toilet flush, and more. And the good news is as SoundTraxx does, every single one of these sound effects has its own volume control. So if you have a model like the one we have here in front of us that does not have an AC unit, you could take the AC volume and set it to 0, so that way you won't be hearing the air conditioning unit on the locomotive that you're running. Now, one of the other things I wanted to point out with this is the Tsunami2 has 16 independent sound channels. Our nearest competitor boasts that they have 10. The reason this is important is because a lot of these sounds that are going on in the background will not be supplanted or superseded to play the horn or the bell. So when the air compressor sound or the radiator fan sounds are being played, you will actually hear that sound even if you blow the horn or ring the bell. Some of our competitors' stuff will actually shut off some of those sounds abruptly so that you can play the bell, and then when you turn the bell off, those sounds will magically return. And our Economy product, which is our budget sound system, actually has 12 independent sound channels. And so Tsunami2 gives us 16. And so we can go through and reproduce all of these background sounds more realistically, and they stay there the whole time rather than stopping and starting based on what you're doing. Now, speaking of based on what you're doing, the air compressor and radiator fans all operate based on how you use the locomotive. So if you're using the brakes a lot, let's say the F11, if you're using that more frequently, you're depleting the air reservoirs. So that means the air compressor needs to charge the air reservoirs. So all of this works interactively to give you the most realistic experience that we can. So when you use the brakes, you're going to hear the compressor cycle on and off more frequently. Also, the poppet valve or the air dryer we talked about, CV200 allows you to adjust the rate. So if you're modeling, say, Houston or Baltimore area where it's very humid versus, say, Arizona in the summertime where it's very dry, you can adjust this CV200 to adjust the rate at which you hear some of those sounds in the background. And then there's the clickety-clack the wheels clicking on the rail, you can adjust that for the number of axles, the length of the locomotive. So starting and running the locomotive on the flat track, engine demand is based on tonnage, and so it may be in run 8 getting that locomotive and that train moving, but only going a very slow speed. And this is where the dynamic exhaust will actually kick in to help give you a more realistic experience. Same thing, if we're running a single or two P42s running a 5-car or 6-car passenger train at speed, it may be dropped down, because once the locomotive is at speed, your prime mover drops quite a bit because you're only maintaining the speed. So this is where the dynamic exhaust gives you a more realistic representation of what's actually going on your layout. And again, you don't have to push any buttons to make it happen. We're going to kind of go through a scenario here of what it would take to start the diesel locomotives.
We're going to go ahead and unmute this guy. Now we're going to go through the startup scenario. So first thing we're going to do is we're going to turn on our headlight. We're going to blow our proper whistle signal, which is we're going to be moving in the forward direction. Now we're going to turn on our ditch lights. We're going to throw our reverser in the forward direction, make sure we're going that way. We're going to turn on the bell. We're going to open the sander valve, which is function 21. Now we're going to open up the throttle, so we're going to go to speed step 1, and then we're going to release the brakes. Now when our locomotive starts to move, you're actually going to be moving at speed step 1 to pull the slack out of the train and get those couplers tight. Now that we've got our traction going, we can turn off our sander valve, turn off the bell, and then now we can increase the throttle. And with a heavier train, you'll go ahead and hear the prime mover notch up and go on the way. So let's go back and take a look at our screen here, and we're going to go through the scenarios. So now you can see that there's a lot more
involved in running our locomotive rather than simply turning the knob and the direction switch. So we turn on our headlight and any other lights that we want, blow our whistle signal, throw the reverser, make sure we're in the forward direction, turn on the bell to let everybody know we're moving, open the sander valve to get some traction, and so forth. So this gives you a little bit more involved. Now once we're moving, now we have to stop. If you're modeling early 50s, they still used a lot more of these whistle signals rather than radio control or radio communication.
So we're going to unmute this guy. Let's pretend we're moving at speed step 20 for right this moment. So to go through the sequence, we're going to blow our whistle signal, which in this case will be a long and 3 short. Now that tells the flagman we're getting ready to debark and make a stop, so he gets ready to get off the train. So now we're moving forward. So now as we get ready to make our stop, we're going to turn on our bell. We're going to open our sander valve to make sure that the wheels are stopped. Now we're going to apply the brakes. And you're going to hear the brakes set. And now when we come to a stop, we can blow our whistle signal, tell everybody that we're stopped. And then our prime mover will drop down to idle. So then at this point, if you're backing up onto a train and you're using the independence, you can use that F13, and that will trigger the coupler sound to automatically go in and make that sound when you're making your couple. Now, some operational tips here. I'm going to go ahead and mute this guy back again. Now, some operational tips here.
Add a little bit of momentum. Real locomotives don't start and stop on a dime, and so add a little bit of momentum, find out what's right for you and your operators so that it doesn't overwhelm them, but at the same time gives them a more realistic acceleration and deceleration. In the case, say if you're moving your locomotive back and you tie onto the train, that's when you would hit the F12 to charge the train line, and that's when you can call and radio the dispatcher, tell them your train line's done, you've done your brake test, you're ready to go. And then again, when coupled with sound car, it creates a really cool sound effect for the entire train. So adding in sound and operation also helps slow down our operation, because now we're doing a lot more and we're more realistically reproducing the work that the real locomotives are doing. And so therefore it allows us to do more in less space. I mean, there's many of us out there that have layouts that are always too small. And so by adding this in, it slows it down, it gives us more function and more purpose in what we're doing, rather than just simply turning the knobs and racing through our switch lists. And then the last thing is I talked about, take the function keys and match them to you and your operator's tastes, or if you have a limited throttles, such as the SoundTraxx UT4s, or I forget what they, NCE calls them, but they're the little D5s or little throttle 5s or whatever, where you only have access to 8 functions. Find out what 8 functions are going to be best for that operator and put those in there as the first 8 functions. And then that way you don't have to worry about, you know, you've got all those sounds in there, and your operators will now enjoy their operation a little bit more. So in conclusion, understanding diesel locomotives is the key to the Tsunami2 development. When we were building this decoder, we had and have current and former railroaders on staff, and so we were using their experience to help us build the decoder so that we could build a more realistic simulation. Anybody can make a noisemaker, but we wanted to give you a realistic simulation of what's going on with the real locomotive. And again, running trains can be more than simply adjusting the throttle knob. We've graduated from DC power packs, and so we want to make sure to give you the most experience that you can and the most functionality. And then when you're using the locomotives more like the prototype, it gives it more fun and a more interactive operating session.